pertains to the lab Dr. Peruse. Today our group will be speaking about our project, which pertains to the level of service, or LOS, of California highways. So our team name is TeamPylon, and our group consists of Leonardo, myself Enrique, Min, Julian, Israel, Manali, and Ryan. So today our group will be speaking about our project's background, our data sets, descriptive, predictive, and prescriptive analysis that we made, as well as our conclusion.
From the start, we wanted a project idea that was applicable to the real world, that had some sort of impact on people's daily lives. This project came about with the help of Caltrans District 6, with the goal of testing if it is viable to calculate the level of service for California highways by making assumptions for the road conditions. The problem with this right now is that Caltrans right now, in order for them to get information, they either use the sensors that are aligned throughout the highway or manually go out into the field and count them manually. If we were to assume some of the counts, we would be saving them a lot of money. This would be done by saving a lot of time that are spent out in the field. Level of service is actually broken up into 6 categories. Level of service A, which is the first one, shows that there are low amounts of traffic. Drivers do not affect each other either, and that is shown by the picture to the side right here on the right-hand side. Level of service B shows that there is a stable amount of traffic and the drivers are starting to begin to affect each other, but it's not something that they're going to notice that much. Level of service C, which is the third one, is showing that the traffic flow starts to become restricted and drivers are often affecting each other. And this is a step where people will start to notice. Level of service D is when traffic flow is heavily restricted but is stable, and the speed and maneuverability is severely affected. So meaning the speed limit you're going to probably go at below or just at. Level service E means that the traffic flow becomes unstable and you are at the capacity of the highway, and the highway cannot go above more or it's going to get really bad. The really bad level is depicted by level of service F, and that is pretty much that traffic flow is becoming forced because it is exceeding capacity.
So now about our data sets. Our data sets consisted of Excel sheets that contain data from the years 2015 to 2019, which was the most recent data that we were able to get a hold of. That held the hourly traffic information needed to determine LOS, as well as the Excel sheets that hold traffic data for trucks. And these are two separate Excel sheets because truck data is a variable that is needed to determine LOS, but is found separately. And then from Caltrans's website, we use GIS Open Data as geographical data to determine the data for certain roads to calculate LOS. So in order to solve the problem of efficiently calculating LOS, we needed to create a generalized method of calculating LOS using the data given by Caltrans. And in order to do this, we needed to assume the number of lanes and the speed limit of each road on which cars would be driving on. So here we have an excerpt from our hourly traffic information dataset, which holds the district that this portion of the highway is, as well as the highway route. And then you can see the county. You can see that there is a location description, and then you can also see that there's a daily averages of how much highway traffic is actually on that part of the road. And then there's also a count for how much traffic per hour is on the road from 1 a.m. All the way to noon and then to midnight.
The first task we did for descriptive analytics after cleaning data was graph the hourly traffic rates for both the AM and PM. This figure shows the AM hour plotted with the volume of the respective hour, and it can be seen that the traffic rates increase as the day approaches noon. The key feature to be noted from this bar plot is the 4-hour interval with the highest flow of traffic being from 9 a.m. to 12 a.m. The same bar plot with the PM hourly traffic data has its 4-hour interval with the highest flow of traffic being from 2 p.m. to 5 p.m. Both these values are significant as they are used to calculate the LOS of AM and PM. After using these values to calculate the LOS, we can compare the LOS values of AM and PM to see the change between them. As seen on the alluvial graph, there is a noticeable shift from the LOS-B and AM to other LOS categories in the PM, such as the shift of about 30% of the B category changing to the C category of LOS.
By analyzing previous data, we were able to see that the traffic volume escalates at a rate of 2.5% every year. Here is a data analysis of year 2019. We can see that the majority of LOS falls in the range A, which means Highway 99 is in a good standing. The lower the level, the more dense the traffic becomes. By forecasting data for year 2020, we don't see the much difference in the result. There is the LOS A is slight less than the 2019 because of the traffic escalation. We try to do analysis without RAMs also, because RAMs are the major factor which improves the quality of services on roads. And here is the forecasting without LOS for year 2020.
Now, moving forward from the pie charts, we have a different way to visualize the difference in LOS from a year to the next. In this case, we have an alluvial chart which shows the transition from LOS of the current year, which is 2019, to the predicted LOS for 2020. And you can see again, just like in the pie charts, that there is not much difference, with just a small percentage of each road declining in terms of LOS. Now, this is a different alluvial chart. This is an alluvial chart representing the accuracy of a KNN algorithm for predicting LOS. We ran several tests. We tried some regression algorithms and KNN, and we found that KNN was the more accurate algorithm for predicting this specific LOS, but it's still not great with only a 74% accuracy rate, but still way better than the regression one, which had only 40% accuracy rate. And this graph essentially just shows actual LOS versus predicted LOS. So you can see here on the A, it predicted most of them correctly, but with a few of them being predicted in the B range. And the same goes for all the other LOS categories. But even though this algorithm has a 74% accuracy rate, it is far from ideal to implement at Caltrans, since it has inaccuracies, big inaccuracies in some aspects. For example, the predicted LOS for the F tier, some of them got predicted to go up, which makes no sense. We found volume is the variable that impacts LOS the most, specifically volume at the peak hours. And speaking of peak hours, we found that the peak hours are not exactly the same as common sense would dictate. Also, we found that the difference in LOS on roads after only 1 year does not change much, with only a small percentage of the roads declining in LOS. And lastly, that there is a difference in the LOS on the AM section versus the LOS on the PM section. Most of the time, the PM sections have more traffic in it, so the LOS tends to be worse. And lastly, we would just like to thank Dr. Peruz for approving this project, and also everyone at Caltrans for providing us with the data necessary and information on level of service so we can do a more in-depth research on it. And that's it. Thank you.